Right now, as you're watching this, galaxies are vanishing, not dying, not exploding, just disappearing beyond an invisible line we can never cross. Every second, thousands of stars slip past our cosmic horizon forever. And here's what keeps scientists awake at night. We can only see 0.001% of what might actually exist out there. But that's not even the strangest part. What if I told you the Big Bang might not have been the beginning? That the void of space is somehow alive? That black holes could be creating entirely new universes right now? And that our entire reality might be trapped inside a bubble, destined to either freeze, rip apart, or bounce back into existence? Again and again and again. Tonight, we're drifting to the absolute edge of everything we know, to the questions that make even physicists uncomfortable. Because the deeper we look into the cosmos, the more we realize the universe isn't just stranger than we imagine. It's stranger than we can imagine. If you feel even the smallest spark of wonder, hit that like button and subscribe. Your support shapes these journeys. Now, let's begin. Part 1. Before the beginning. What existed before the Big Bang? It sounds impossible, like asking what's north of the North Pole. Yet some of the most brilliant minds in physics believe there's an answer. We know the universe began roughly 13.8 billion years ago, expanding from unimaginable density. But ESA's Planck satellite revealed tiny irregularities in the oldest light, patterns that may hide something extraordinary. Evidence that the Big Bang wasn't the first enter the Big Bounce. Instead of beginning from nothing, the universe might rebound endlessly, expanding, contracting, then expanding again. Loop quantum gravity suggests that space is woven from the smallest possible loops, and when the universe gets too dense, these loops push back, preventing complete collapse. The universe bounces, even more mind-bending. Stephen Hawking's no-boundary proposal suggests time behaves like Earth's surface, curved, but without a starting point, with no edge, where north turns to south. The James Webb Space Telescope found galaxies far more massive than predicted, existing just 300 million years after the Big Bang. Could that extra structure belong to a cycle before ours? The beginning was never the first, only the latest. Part 2. The living void. What if nothing isn't empty at all? According to quantum field theory, even the deepest vacuum trembles with microscopic energy pulses, creating and destroying particles too quickly to measure. This vacuum energy accounts for nearly 68% of all cosmic content. Most of reality comes not from stars, but from the energy of empty space itself. Here's the unsettling part. If our universe exists in a false vacuum, it could collapse into a lower energy state, rewriting the laws of physics instantly, spreading at the speed of light with no warning. But there's hope. CERN. Physicists calculate such an event won't occur for trillions of years. By then, the universe will have cooled into near stillness. The leading theory of cosmic inflation suggests our entire universe began as a single quantum fluctuation, a tiny bubble of energy emerging from nothing. Everything, from the smallest atom to the farthest galaxy, born from a whisper in the void. Even in darkness, particles dance. Even in nothing, there is life. Part 3. The eternal return. Imagine the farthest future, trillions of years from now. Every star has burned out. Every galaxy has drifted apart. The sky itself fades to black. Yet something extraordinary may be waiting. The possibility that the universe could begin again. The Big Crunch suggests gravity might one day reverse expansion and pull everything back together. In Roger Penrose's conformal cyclic cosmology model, each universe expands and cools until particles lose their sense of time. Then, the geometry resets, and the next Big Bang begins. When density reaches the Planck scale, Gravity becomes repulsive instead of attractive, transforming the final singularity into the seed of the next universe. It's perfect symmetry, every end folding seamlessly into a beginning. Penrose suggests traces of this inheritance might appear as faint rings in the cosmic microwave background, ripples overlapping from a previous universe. In the grand design, every end echoes the first breath. Part 4. Time's Slow Death. There's a quiet rule governing everything: entropy. It's why coffee cools, stars fade, and galaxies dim. Entropy always increases, giving time its arrow, moving the universe from order to disorder. Eventually, this leads to heat death, a state where no temperature differences exist anywhere. The cosmic background radiation, now just 2.725 Kelvin, grows colder as the universe expands. In the distant future, even the faintest stars will burn out. When black holes evaporate through Hawking radiation and protons decay, after 10 to the 34th years, every atom will disintegrate. At around 10 to the power of 100 years, all meaningful activity ends. But here's the twist. Quantum fluctuations might still occur even in a nearly dead universe, creating bubbles of new spacetime, miniature universes emerging from the ashes. Time wouldn't die. It would only fade from one cosmos and awaken in another. Part 5. Gateways in Darkness. Black holes were once thought to be cosmic endings. New research suggests they might be cosmic beginnings. Stephen Hawking discovered black holes emit faint thermal radiation, slowly evaporating over time. If they can release information, they may not be endings at all, but transitions. Some physicists suggest black holes serve as gateways, with matter tunneling through to form new expanding regions of spacetime. Loop quantum gravity predicts a bounce where density reaches maximum then reverses, creating a burst of expansion that looks like a Big Bang from inside our own Big Bang might have been the rebound from another universe's collapse. According to string theory's brane cosmology, when two universe branes collide, the impact could ignite a new universe. Perhaps the Big Bang was simply a spark from a cosmic collision. Black holes don't only end systems, they build them. Each collapse might be a creation, each silence, a spark. Part 6. The silent spaces between galaxies lie vast regions of almost nothing, cosmic voids. The Bode's void stretches over 330 million light-years across, containing only about 60 galaxies, when there should be more than 10,000. The Eridanus supervoid may span up to 1 billion light-years, aligning with a strange, cold spot in the cosmic microwave background. These voids aren't empty. They shape how we see the universe. As light travels across a void, it loses energy through the integrated Sachs-Wolf effect, explaining why photons from that direction arrive cooler. Recent observations reveal that even the emptiest parts of space contain wisps of gas, threads of dark matter, or tiny galaxies too dim for previous telescopes to see. In the silence between galaxies, the universe whispers its oldest secrets. Part 7. One among billions. Everything we can see, every star, every galaxy, might be just one bubble floating in a vast, invisible sea. Physicist Alan Gough's inflation theory suggests the Big Bang was not unique. In some regions, inflation ended, creating universes like ours. In others, it continued, creating more bubbles. This is eternal inflation, and it implies countless universes exist. ESA's Planck satellite searched for subtle circular patterns in the cosmic microwave background, possible scars of another bubble colliding with ours. In the many worlds interpretation of quantum mechanics, every possible outcome of every quantum event actually happens, each in its own branching universe. Universes multiply constantly, splitting with every moment. NASA astrophysicist Michael Turner said, "The multiverse may be the ultimate extension of Copernicus's idea. We may not even be the only universe." Infinity doesn't mean endless space. It means endless possibility. Endless. Part 8. The horizon that hides everything. We don't see the universe as it is, only as it was. The observable universe stretches about 46.5 billion light years in every direction, limited not by space, but by time. By how long light has had to travel since the Big Bang beyond our horizon, galaxies are moving away faster than light, because space itself is stretching. ESA's Planck mission measured that for every 3.26 million light years of distance, space expands another 44 miles per second faster. The cosmic microwave background, mapped by Planck with extraordinary precision, is the oldest light in existence. The afterglow of the Big Bang released when the universe was only 380,000 years old. ESA scientists calculated the universe's curvature to be extremely close to zero, suggesting space may extend forever or loop back on itself. The universe may have no edge, only layers of visibility. What we call the end is only where our light fades. Part 9, Trapped in the Bubble. Here's the haunting truth. Beyond a certain limit, galaxies are fleeing faster than light. We will never see them, not now, not ever. It's as if we're inside an invisible bubble of visibility. In 1998, observations revealed the universe's expansion is accelerating, driven by dark energy, accounting for about 68% of the universe's total energy. Galaxies more than 16 billion light-years distant are already receding faster than light can travel. In the far future, hundreds of billions of years from now, the only galaxies visible will be those bound by gravity in our local group. Everything else will have disappeared beyond the cosmic horizon. Future astronomers will look up and see only the Milky Way. The rest of the universe will have vanished. The universe isn't ending. It's slipping away. Part 10. The final unraveling. If expansion never stops, if it accelerates beyond every limit, the cosmos may one day tear itself apart. The Big Rip begins with dark energy. If its strength increases over time, expansion will accelerate until even the smallest structures are torn apart. Over the next tens of billions of years, the expansion could grow so extreme that even gravity, electromagnetism, and the strong nuclear force begin to fail. Here's the timeline. In 100 billion years, distant galaxies disappear beyond our horizon. By 150 billion years, planets will be torn from their orbits. Eventually, space expands so rapidly, it stretches the very fabric of atoms. Electrons can no longer orbit nuclei. ESA's Planck mission measures dark energy's parameter at roughly -1, placing us at the delicate edge between eternal expansion and future collapse. The Big Rip isn't an explosion. It's a fading. Not with a bang, but with every note in the cosmic symphony slowly disappearing. Yet even that silence may not be forever. Quantum fluctuations could still ripple through the vacuum, birthing new universes, just as one fluctuation may have sparked our own. Take a slow breath. The stars above you tonight are still bound, still shining, still connected. But you've just glimpsed what lies at the edge of everything, the questions that define our place in an incomprehensible cosmos. If this journey moved you, hit that like button and subscribe. Drop a comment telling me where you're watching from and what cosmic mystery keeps you awake at night. Your words guide these explorations. Until we meet again under another sky, may your nights be calm, your dreams vast, and your mind open to the quiet wonder that surrounds us all. Sleep well, dream softly, and remember, we're all drifting together through this beautiful, terrifying infinity.